everyone. This is Parimala, working as an assistant professor in the Department of Computer Science and Engineering at Ignas Foundation for Science, Technology and Research University. Today I am here to discuss about the concept called switching from computer network subject. Before coming to that, first we need to discuss about what is a switching. Switching is the process of moving the content from one device to another device. The two devices may belong to the same network or the two may belong to different networks. Means process of sharing the content within the network or across the networks is called switching. Mainly the switching focus on finding the best path between source and the device. And here it decides how to move the content, in what way the data need to be traveled. That will be identified by the switching. Usually switching will be performed at two layers of OSI. One is a network layer and the other one is a data link layer. Based on the type of switching what it is using, it decides to use either at the network layer or at the data link layer. So switching is one of the functionality of network as well as the data link layers of OSI model. Coming to the best properties of a switching. Switching having many basic characteristics as well as the properties. In those, the first one is nothing but addressing. What do you mean by an addressing? Addressing is nothing but what the functionality of the switching, moving the content from one device to another device. What the two devices are, where the two devices are, then only it can carry the content. So it need to identify the address of the source as well as to whom the data is going to be forwarded, nothing but the destination. So the first functionality of the switching is identifying the address of source as well as the destination. That is the first functionality, first property. After identifying the path, it need to decide how to go. Deciding how to go is nothing but finding the path, also called a route. So a route will be identified or established between the two devices, source as well as the destination. Path will be identified or path will be selected, or we can also call route identification. So first thing is nothing but addressing. After knowing the address, it should identify the path, how to reach. After identifying the path, it need to decide is it through the network layer or through the data link layer. That need to be identified. Is it through the switch or through the router? Switch is the component which is used at the layer 2 and router is the another hardware component used at the layer 3. As well as in the previous slide, as we discussed, that switching is the functionality performed by both network layer as well as the data link layer. Here it decides what type of switching it is going to perform. Is it layer 2 switching or layer 3 switching? That will be decided after finding the path. And then it uses the mechanism called store and forward. Here the name it clearly specifies store and then forward. So without simply blindly forwarding the content to its next, first it stores a copy of that in its routing table and then the data will be forwarded to the next. That mechanism is called store and forward mechanism. Usually when the data is carried from one user to another user, blindly forward the data. But coming to here in the store and forward method, first it take a copy of that. A duplicate copy will be maintained by that node and then that will be carried to the next or will be forwarded to its next node. After this functionality, next it identifies what type of connection the two devices has. Means the source and the destination. What type of connection the two devices are having. Is it connection oriented or connectionless? Connection oriented is nothing but there is a physical path between the two devices. Connectionless, there is also a connection but it is a dynamic connections. So first after that it need to identify what type of connection the two devices contains. So based on that, here it decides how much bandwidth need to be utilized. Coming to connection oriented, a specific bandwidth will be used. Coming to the connectionless, another type of bandwidth need to be used. So based on the type of connection what the two devices has, it decides how much bandwidth need to be utilized. Based on that, it comes for the forwarding. During the transmission, it also performs a basic thing called error handling. During the transmission, due to any of the noise or any disturbances, the data may be corrupted. That is error handling mechanism. Finally, after reaching the data to the destination, it decides how much time, it calculates how much time it has been taken to reach the data to the destination and with what delay the data get carried. For suppose, here the data is forwarded at the first time clock and it expects that the data should be reached to the destination by the third clock pulse. So a clock pulse of the 2, it expected the data will be reached to the destination. But finally after reaching to the destination, it identifies at what time the data reached to the destination. Approximately assume it as a 5 seconds or 5 clock pulses. So it expected that it should reach by the third clock pulse, but it reached at the 5th clock pulse. So there it identifies, after sending the data to the receiver, there it identifies with what delay the data get carried. Suppose if the data is sent at the first clock pulse and it expected the data will be reached to the destination at the third clock pulse, but it reached at a 5th clock pulse. So it identifies the gap between the two. So 3 to 5 means a 2 seconds of 2 clock pulses delay. With that delay, data get carried. Likewise, these are the basic properties of switching. Then we will move to the principles of switching. What are the basic principles performed by the switching? The first one is nothing but multiplexing. Multiplexing is nothing but as there are many users in the network, one user may contact to any other user at any time. So it decides which user connecting to which user. So allowing multiple users to share the data in the network is nothing but multiplexing. Efficient path utilization. As the many users were there, all those users were connected with many paths. So as one user is connected to any other at any time, it need to decide the efficient path to carry its information and with a minimum delay. So as possibility there with a less delay, it expected to share its information. The propagation delay should be minimized. And the next property is nothing but reliability. Reliability means guarantee of reaching the data to the destination. As there it ensures that the data will be reached to the destination at any of the time. Scalability. As once the switching performs for the 2 devices or 3 devices, it will be adopted to any number of devices at any scenario, at any traffic. That is nothing but scalability. Nothing but switching supports increasing the devices at any traffic. As the switching applied to the 3 devices, it performs well, and the same you applied for the 10 devices, it performs well. As the same you apply for the 100 devices, it performs well. That is called scalability. Increasing the number of devices also, it performs well. Isolation of the traffic. As many devices, as the number of devices get increased and all the devices are trying to share information at random amount of times, there will face a common issue called congestion. What is congestion? Congestion is nothing but overloading of a network. As many devices, here we have seen it is scalable, means it works for any number of devices. So in such cases, in general, we will face an issue called the congestion. So it also prevents that isolation of the traffic from the congestion control. And the next property is nothing but efficient utilization of the bandwidth. Instead of wasting the bandwidth for unnecessary things, better utilization of the bandwidth is another important property, and collisions will be reduced. Along with that, for any kind of the network, for any scenarios, this switching will be applied. These are nothing but basic principles of our switching technique. And there we have many types of switching techniques. Usually we have 3 basic types called circuit switching is the first one, packet switching is the another type, third one is the message switch. This packet switching is having 2 subtypes called datagram switching, virtual circuit switching. These are the basic types of switching techniques. In this, here just we'll go with a brief description of all the 3 types of switching techniques. That is nothing but first we'll move with the circuit switching. What the circuit switching means? Circuit. Here it decides, this is basically for connection oriented service. What the connection orientation means? As there is a physical path between source and the destination, that we call as a physical connection oriented services. As there is a physical path, a dedicated path will be identified or a dedicated channel will be identified. A physical path will be available between 2 devices. Where we have a physical path, moving the data from source to the destination through that physical path by identifying the specific route is called circuit switching. First it establishes the connection and then the data will be carried, finally disconnect it. That is nothing but a first switching technique. Coming to the second one, packet switching. There is no physical path, there is no direct path, there is no predefined path. But without path it is highly impossible to carry the information. Then how it forward the data? Which is a dynamic connections. Dynamic path will be identified. So the large information usually divided into the small chunks. Usually we call it as a packet. That will be sent from one user to another user independently. That is called packet switching. Each chunk we call as a packet. Coming to the last one, message switching. Message switching is nothing but instead of making the message into the chunks, the entire message, irrespective of the size of the message, the entire message it try to forward at a single attempt. That is called message switching. In that message switching, here it uses a mechanism called store and forward technique. So these are the three basic types of switching techniques what we have, that is circuit, packet as well as the message switching. Here just we discussed about the brief introduction about the circuit, message as well as the packet switching and the network switching types, and detailed information about that we will see in our coming videos. Thank you everyone.